what do we know about our denominators? They have to be the same. Okay, so if you read the top, it says to add or subtract, you must have a least common denominator. Technically, you can have any common denominator, but the least common denominator is going to make your life easier. Okay? So if you look at number 1, what is their least common denominator? X. They're already the same. Now, let's go ahead and talk about domain while we're looking at it. Okay, so what can your denominator not be? Remember, it's okay to have a 0 on top. It's not okay to have a 0 on bottom. So what can X not equal? 0. Okay. Now, since our denominators match, I want you to realize that means you bring them together with a single denominator. If you notice, I didn't write it twice. They combine. And 2 minus 5 is negative 3 over x. That doesn't simplify, so that is my answer. Number 2 is a little different. Okay. What is my least common denominator here? 20. 5 and 4 can both turn into 20. Okay, and well, how do I turn a 5 into 20 by multiplying? Times 4. So on this side, we're going to multiply both of them by 4. What about this side? Well, 5 times 4 and 4 times 5 equal 20, so I know that this whole thing is going to be on top of 20 now. And we have 4 times x, which is 4x, and 4 times 2, which is 8. That's the left side. Minus, be careful when there's a minus, that's why I'm using these parentheses. 5 times x, which is 5x, and 5 times negative 2, which is negative 10. Now, the reason you have to be careful when there's a minus is because we're taking away everything in this fraction. Typically the top, we're just combining tops. So I have to distribute that negative to both things on top of that fraction. So this becomes, I'm going to rewrite the left side, 4x plus 8 minus 5x. 2 negatives makes a plus 10. Okay, when I combine like terms, 4x minus 5x is negative 1x. 8 plus 10 is positive 18 over 20. Now, technically, I could take a negative 1 out of the top, but that can't simplify anything, so we're okay. So this is our answer. But what do you think our domain is? Are there any letters on the bottom? So x can be anything. The fancy R for all real numbers. X is all real numbers. Because there's no letter on the bottom, x can be anything. Okay. Huh? Okay, look at number 3. What do you think our least common denominator is going to be? 15 is the number, but there's more to it. Just A and a C. Because I can multiply the left side by 3, and that will become 15AC, correct? What would I multiply the right side to make it become 15AC? 5 what? Mm-hmm. So now I know my denominator becomes 15AC for both of them. 3 times 2x is 6x plus 4 times 5 is 20. And remember, we put letters in alphabetical, so CY, not YC. And nothing here can simplify. You could technically take out, what's your GCF on the top? 2. Does 2 go into 15?
No.
So would it change anything if I took it out? No. Now, what can A not equal? 0. And what can C not equal? Because there's no plus and minus in the denominator, they just can't be 0. Because it's only multiplication down there, so it's just 0. Now, if you notice on number 4 and 5, there's going to be some factoring. I'm actually going to do the factoring for you because we've been doing factoring for a really long time. So hopefully you understand how to get these. If this was a test problem, this is how it would be set up for you anyway. There might be some that aren't factored, but it's not going to be like yesterday. You know how some of them, like all 4 pieces weren't factored? We're not going to have anything like that on there. There might be like 1 piece to factor, but not all 4. Okay, so what do you think our least common denominator is going to be? That's part of it. So here's my question. What is this one? What does this one have that this one doesn't? No, they both have x plus 1. That x minus 2. So we have to give it to this one. Now what does this one have that that one doesn't? Now, I want you to realize our least common denominator is x minus 2, x plus 1, x minus 3. So before we keep going, what can x not equal?
0.
It could be 0. Watch. If I plug in 0 for x in the denominator, I get 0 minus 2, 0 not negative, minus 3, and 0 plus 1. Did that equal 0? So is 6 okay for the denominator? Yeah, so 0, it can be 0. Now, I want you to realize this is a factor, factor, factor. Each set of parentheses represents a factor. Therefore, each set of parentheses cannot equal 0. What would make this minus 2 equal 0? Positive 2. What would make this positive 1 equal 0? What would make this negative 3 equal 0? Now, technically, those should be in least to greatest, but it's fine. Do you see what I'm saying? Okay. And you could technically plug those in, and you'll see if I replace the zeros with a 2, because the 0 is where the x was, it equals 0. And remember, it's not okay to have 0 on the bottom. Okay. If you don't realize the way I thought about it, remember you can set them equal to 0 and solve them. So add 2, x equals 2. Do y'all see what I'm saying?
Yeah.
Okay, so you could do it that way as well. So let's keep going. We're going to double distribute. What's x times 7x? Sorry, I'm just writing the denominators. Yes, it's 7x squared. X times negative 1 is negative 1x. Negative 2 times 7x is negative 14x. Negative 2 times negative 1 is positive 2. Now, I want you to realize that this is a minus. Do you think I could give that negative up here and distribute it all at once? Because remember, I'm going to have to distribute that negative like we did in number 2. Could I do it now with the 6x? Yeah. So I'm just going to move it here, and I'm going to distribute it together. So I get negative 6x squared plus 18x. So we are going to combine like terms. I have 7x. Yes.
So you only distributed the x for the first one?
For the first one? No, I distributed the x minus 2.
Okay.
There's the x. There's the negative 2 distribution. Okay, so then we're going to combine like terms. What's 7x squared minus 6x squared? 1x squared. And then I have negative 1 minus 14x. Well, negative 1x minus 14x, which gives you negative 15x, plus 18x, which is going to give you a positive 3x. And then I have plus 2 over this denominator. Now, can we factor the top? Well, I mean, we could test it and see. A is 1, B is 3, C is 2. A times C is 2, B is 3, AX, AX. What multiplies to give you 2 but adds to give you 3? 1 and 2, which don't simplify, so we end up getting x plus 1, x plus 2, can it simplify? Like yesterday?
Some can.
Which one?
X plus 1.
The x plus 1. So your final answer is x plus 2 over x minus 2, x minus 3. Okay, any questions? I know that one's a lot. But let's look at another one. Kind of similar, but not as much. Okay, again, I'm going to factor the bottoms for you. So what would our LCD be? So what does that make all together? Those 3 factors. And then you were right. This one's missing the x plus 4. This one's missing the x minus 1. And the nice thing is this one's plus, so we don't have any distributing of negatives to worry about. Okay, so we're going to distribute. Now that they have a common denominator, I'm just going to write the denominator once. So x times x, zoom in, yeah, is x squared. X times negative 7 is negative 7x. 4 times x is positive 4x. 4 times negative 7 is negative 28. 3 times x is positive 3x. 3 times negative 1 is negative 3. So now we're going to combine like terms. Are there any other x squareds? No. So if you get stuck on the top combining your like terms, you can type them in your home screen without the x. So negative 7x plus 4x plus 3x is 0x, so it's gone. And then negative 28 minus 3 is negative 31. Now, this has something squared. Can I factor that further? Not quite. Is 31 a perfect square? No, x is. So this is not the difference of squares, therefore we cannot factor it further. So that makes it nice because then we're done and there's no more extra steps trying to cancel. But one thing we haven't found yet is what can x not equal? Well, what cancels a positive 4? Positive 2 and negative 1. Okay, last one. It's not as bad as it looks. Okay, so if you notice we have two that aren't fractions, so we have to make them a fraction. And when you're making something a fraction that isn't already a fraction, you just put it over 1. Okay? Well, what do you think our least common denominator is going to be here? X plus 5. Because the cool thing about having a denominator of 1 means I can multiply it by whatever I want to give it to become whatever I want. So this already has an x plus 5, so let's make those have the x plus 5. So we're going to multiply top and bottoms by x plus 5, but this one I'm leaving alone because it's already what I wanted. Those are all really tiny x plus 5s, by the way. So I know my denominator is going to be x plus 5. What's x times x? What's x times 5? Positive 5x. 2 times x? 2 times 5? And then I'm just going to bring over that plus 3 that we didn't have to change. And now we're going to combine like terms. So I have x squared with no like term. 5x plus 2x is 7x. 10 plus 3 is 13 over x plus 5. Now, this could simplify. A quick check. Does 5 go into 13?
No.
So if we factor it, there's not going to be an x plus 5 on top, so you can't simplify it anyway. But even if you try to factor it, you end up getting 13 on top, 7 on bottom. Y'all, is there anything that multiplies to give you 13 but adds to give you 7?
No.
And it's because it's prime. So this is your answer. And what can x not equal? It can be 0. It can't be negative 5. Because if I plug in a negative 5, what's negative 5 plus 5?
0.
0. Okay, so that is your notes.